Well, I'd like to welcome everyone, contestants and guests, to the 3-minute speech competition. This is, of course, the 10th annual Student Research Symposium, but I believe it's either the 8th or the 9th year that we've done the 3-minute speech competition. My name is Dr. Steve Simpson. I'm the Dean of Arts and Sciences, and I'll be emceeing your event. With us today, we have 3 judges from across campus who will be making the decision about who wins the competition. I'd like to introduce our judges. First, from the Department of Biology, we have Professor Ben Duval. Ben, if you could say hi.
Hello.
Thank you. And from the class department, currently an instructor in public speaking and in Portuguese, we have Aga Gabor.
Hello, everyone. Hi.
And then from the Office of Student Learning, we have Katie Teams Norris.
Hello, everyone.
So those will be the 3 judges. We also have a number of contestants today. And in fact, if you're not aware of it, in the chat, I'm going to put a link to our list of contestants, and we'll actually be going in order as they're on this list. A little bit about this competition before we get started. So some of you might not know that this is actually an international competition. So internationally, this is known as the 3-minute thesis competition. It started actually at the University of Queensland, Australia in 2008. And the story behind it was there's a graduate dean of the University of Queensland, and they were going through a drought, and everyone was given these little hourglasses with a suction cup that you could put inside your shower, and each one was set so that it timed out 3 minutes. And it was one morning as the graduate dean was taking a shower, and of course, as with all of us, the best ideas come to us when we're in the shower. And he saw that little hourglass clicking down, and he thought, you know, this actually would be a good way of providing my graduate students with the opportunity to learn how to present their research in a very quick and efficient method. And it was thus that the international 3-minute thesis competition was born. Internationally speaking, this is a graduate student event, but one thing that's differently here at New Mexico Tech is that we also opened this up for undergraduates. And that's one of the reasons why locally we call it the 3-minute speech competition. However, in the past, and I think this might be true this year as well, the graduate student who wins this competition, or the highest scoring graduate student, gets to be the New Mexico Tech representative that advances to the Western Association of Graduate Schools 3-minute thesis competition. So we're kind of the staging grounds for entering into the international competition, if you'd like. Other than also allowing undergraduates, we do follow all of the international rules. And so I'd like to real quickly go over these rules, if nothing else, as a quick reminder for the contestants. Of course, you're only allowed one single static PowerPoint slide. And since you've already given those, turned those into the SRS, we know that all of you are in compliance there. You're not allowed any additional electronic media, no sound files, no video files. You're not allowed any props, no costumes, musical instruments, lab equipment, cute animals, zombies, no props. You're limited to 3 minutes. If you go over, you're disqualified. Presentations have to be in spoken words. You can't sing or rap or anything like that. The way that we'll work the time, and Sarah, if you could advance to that next screen, whenever you get yourself situated, when we call your name, we'll give you kind of a couple seconds to do the. Can everyone hear me? Can you see my screen? And as soon as you're ready, Sarah is going to start the timer that's at the bottom right hand of your slide, and this is what you'll see. You'll see a countdown, and then your 3 minutes will begin. And so you'll get to actually see, how close you are. And as soon as that hits the timer, you're done. No, and then the last thing that's very important, no note cards or notes are allowed. So you can't read off anything. You need to present from memory. Whenever you're presenting, presenters, we ask that you turn on your video and unmute yourself. Otherwise, when you're not presenting, you can definitely keep yourself, everyone should keep themselves muted. And presenters, you can, if you're not presenting, you can turn off your videos if you'd like. After the competition, the judges will deliberate, will be scoring you on 3 criteria. General comprehension. Remember that this is a presentation to the general broader audience. It's not something that's intended for technical specialists in your field. Engagement, how well did you engage and interest your audience? And style, and that goes from everything from your presentation mannerisms to how well you put together your slide. And then we will announce winners later today. The top 3 placing students will win, from what I heard, external hard drives of various shapes and sizes. So rules, just a few practical things for those who are viewing. First of all, the best viewing method for those of you watching, if you go to the upper right hand of your Zoom, you should have the opportunity for side-by-side speaker, and that allows you to see the screen that's being shared. All of the slides will be shared from our SRS rep, and you'll see the speaker alongside that. And you can actually adjust that so that, you can get them the same size. Also, please, when as people are presenting, please make sure that you're on mute. And the last thing is that in between the presentations, in addition to getting the judges' feedback, we let the other contestants give feedback to the contestants. And between each presentation, a slide will pop up. And with the slide, there's a little poll. And you'll also be asked to give feedback on the how well the person did. In between each contestant, in addition to having the poll, of course, the judges will be making notes. And I'll make sure that the judges have all had an opportunity to finalize their notes before we move on to the next person. Are there any questions from anyone? Hearing none. I'd like to move to our first speaker. Our first speaker, Ahmed Momani, is a graduate student in mechanical engineering, and his presentation is AI-based damage assessment of buildings after earthquakes using drones.
Thank you. Okay, can I start?
Yep, so are you all ready?
Yeah.
All right, then let's get started.
Hello, everyone. I am Ahmed Momani, a grad mechanical engineering student at New Mexico Tech. In this presentation, I want to talk about the portion of my research study here as a PhD student. Then let's start. Assume that we are in an extreme situation like after a strong earthquake. What are your immediate concerns? Of course, one of them is finding safe places. We need some safe buildings for immediate occupations. Conventional methods relies on expert judgment. These methods need the expert to show up in the field, walking through the buildings and assess them individually. These type of procedures may take a long time, about days or even weeks. Then implementing an automated method is necessary for these type of extreme situations. These methods not only can perform in a short time, but also they can objective process. Then we designed an automated real-time artificial intelligence-based method to overcome this challenge. The first step in this procedure is immediately finding the nominated safe places. Then for this step, we have two analyses. First, by comparison the satellite image before and after the earthquake, we can have an estimation of overall condition happened for the buildings in the damaged zone. And we can find the damaged buildings, infrastructures like bridge. Next step here is based on using drones. The drones equipped with high resolution cameras, and using these videos, the overall shape of buildings is compared with cuboids, which are assumed as conventional undamaged shapes. Then using the information captured during two previous steps, the first analysis is performed and nominated safe buildings are selected. Then feedback sent to drones to this for the subsequent maneuvers to collect more detailed data. In this step, cracks, which are the first one of the initial signs of damage in brittle materials, are used. The high resolution cameras mounted on drone and investigated to nominated buildings. The challenge for this step is that we need a real-time process. Just assume that as an HD resolution camera with 30 frames per second video, if we have a hand calculation, we have about around 83 million data points per second. As a keyword, we use high dimensional data analytics methods to overcome this challenge. Then the final assessment is performed and the buildings are tagged as safe or unsafe buildings. Thank you for your attention.
Okay, thank you. So at this time, a poll is popping up and we ask for you to give feedback based on three questions: comprehension, engagement, and style. And did the presentation, 4 questions, did the presentation increase your knowledge? And judges, you can score the contestants with the form that you were given rather than the poll. Then our next contestant is Bracy Chester. She is an undergraduate in mineral engineering, and her presentation is entitled Analysis of Copper Mining Accidents in the United States, 2010 to 2019.
Hello,
Bracy?
everyone hear me and see me?
Yep,
Okay,
whenever you're ready.
I'm ready. Hi, my name is Bracy Chester. My team and I have been researching and analyzing copper mining accidents in the United States between the years 2010 to 2019. Mining is an essential industrial activity that involves heavy machinery and hazardous materials. Using the Mine Safety and Health Administration, or the MSHA, data collection of workplace injuries and fatalities within the United States copper mines between the years 2010 to 2019. We collected some of this data and formed trends according to age, mine experience, geographical locations, and other variables. We then made graphs to show these trends. The primary objective of this research was to take these trends, analyze cause and effect, and then to make recommendations for future safety programs that would reduce injury within the industry. If you look at the blue and red line graph, you can see an increase in copper mining accidents beginning in 2017, with an overall decrease in total mining accidents. This increase in injuries within the copper mines was due to increase in production rate and the demand of copper due to electric cars being produced. If you look at the pie chart, you can see the total injury types between 2010 to 2019. The most common type of injuries included struck by, overexerted, caught on, and falling. So we recommended wearing proper PPE, protective equipment, per the job, ensuring that that PPE is properly fitted, requiring more use of handrails and properly marking common trip and fall areas, enforcing vehicle and equipment policies, installing proper signage for the limits of equipment, and the proper training routinely. Thank you.
Thank you, Gracie. And a poll will come up for those of you who are viewing, and judges, of course, you can use the form that I provided you to give your results. And we will move on to our next contestant. Our next contestant is Mel Stevens. She's an undergraduate in mechanical engineering, and her presentation is entitled Crack Filler Robot and Digital Twinning.
Okay, is my headset and everything working?
Yep.
Perfect.
Very, very well.
Perfect. All right, then I'm ready. Hello, and as Steve said, my name is Mel Stevens, and I have the opportunity today to talk to you about my research that I've been working on this semester. My group and I were tasked with answering the question of how do you fill concrete cracks without the manpower of having to pay the labor of humans, because concrete is prone to cracking. As everyone knows, you walk down a sidewalk and there's a bunch of cracks. Most concrete is reinforced concrete, so those cracks cause structural issues. As water and other liquids seep in, it'll corrode away the support beams and cause health damage to the structure. So our team has decided to go with integrating robotics and artificial intelligence to solve this problem. We're going to have a robot that has two types of Intel RealSense sensors. So those sensors will be mounted on the front end of the robot. As it drives around, those sensors will take images of the world around it, and then it'll have the depth and the LiDAR. As you can see on the slide, they're slightly different images. So when those images are taken in and taken into our processing board, we'll use a concept called data fusion. So data fusion will take those two images and make it one complete image for the robot to see the world around it. With that information, it'll then engage our filler system, which is also mounted towards the front end of the robot. So the mounting of the system is also shown on the slide. It'll be parallel to the ground and move X and Y, like left and right, as it's driving forward to fill the crack. So with the complete image from the sensors, the robot will know exactly where the crack is, how deep it is, and the ability to fill it. Right now, our goal is to fill just a straight crack, but we're hoping with time we'll be able to fill more complex and more tree-like cracks. This can be applied with any kind of structure. It can be applied on bridges, on sidewalks. Our main interest was in more harder to reach places, so such as reactors and places that humans can't necessarily get to safely, but a robot going in being able to fill these cracks by themselves would be great. And it'd help reduce risk to injury and structural damage. We've made a lot of progress thus far. We have the sensors working and it's been a lot of fun. We're hoping to display at a conference, and if you have any questions, please reach out. There's still a lot of stuff that we're looking forward to looking into. Thank you.
Thank you, Linda. All right, a poll will appear for the audience and the judges can score using the judging form. And our next presenter is a grad student in the chemistry department, Gehan da Silva, and his presentation is entitled Swinging Electrons for a Better Future.
Can you hear me clearly?
Yep, we can hear you well.
Yep, I think I'm ready.
Okay, go.
Let me ask you a question first. Can modern human civilization function without anthropogenic carbon dioxide emission? For now, the answer is no. In future, we will definitely be able to eliminate or significantly minimize carbon dioxide emission. But by that time, the damage would be irreversible and devastating. We can mitigate the impact of carbon dioxide emission through capturing, storing, and utilization. Capturing and storing of carbon dioxide as bicarbonate has been successfully performed. The first step of the reaction scheme that I have shown here, but without proper utilization, it has no value. Formic acid is a promising value-added product from bicarbonate if we can convert it efficiently. The second step that I've shown in the reaction scheme, our main concern was to develop a photocatalyst which can operate under solar light for this conversion, bicarbonate to formic acid. Titanium nitride is a cheap and durable nanomaterial, which is an active plasmonic material under solar light. The uniqueness of plasmonic nanomaterials is that they have electrons that can interact with incoming light and can oscillate. When they interact with light with unique frequencies, they can increase the amplitude of their electron oscillation, like a simple swing. It doesn't matter how hard we push the swing, but even if we push it lightly, but with the proper pace or frequency, the swing will oscillate efficiently, or in other words, with a higher amplitude. So those oscillating or swinging electrons can be used to drive catalytic reactions. We've hypothesized depositing nickel can increase the catalytic properties of titanium nitride. So during this study, we were able to deposit nickel on titanium nitride using solar light as the energy source for the first time. And we've observed a significant catalytic enhancement for formic acid production. So you can see in the background an electron microscopic image of nickel deposited titanium nitride nanoparticles. And I have circled some nickel depositions on titanium nitride. The red circle shows a clear site of nickel deposition if others are not that clear. Most importantly, this nanocomposite has the potential not only to convert bicarbonate to formic acid, it can catalyze the conversion of carbon dioxide to bicarbonate too. So therefore, this nanocomposite will serve as a photocatalyst from the capturing of carbon dioxide to utilization of carbon dioxide. So finally, I can say we were able to efficiently swing electrons to overcome one of the greatest threats that the modern world is facing. Thank you.
Okay, thank you. A poll will come up for the guests. And judges could use the judging form. And we'll be moving on to our next presenter, Hannah Lambertson. She's an undergraduate student in the biology department, and her presentation is entitled The Mechanisms and Importance of DNA Repair in Halobacterium. Hannah?
All right. Hi. Can everyone hear me?
Yes.
Okay. Great. All right. Then I am ready. So hi, as Dr. Simpson said, I'm Hannah Lambertson, and I am an undergraduate in the biology department. And I'm going to be talking to you today about my research regarding halobacteria. So to begin, I want to pose the question, what comes to mind when you first think of radiation? Is it something like X-rays, or nuclear power, or the sun? Regardless of what first comes to mind, all radiation has a huge impact on human life and health. We all experience radiation on a daily basis, so it's critical that we understand how it can impact human life and how it works. One of the largest and most considered effects of radiation on the human body is its potential to cause DNA damage through double-strand breaks, as is shown on the figure on the left. Essentially, when this happens, there are three scenarios that an affected cell can go through. The first is on the top, and it's DNA repair, where the cell survives and there's no issues. The second is cell death, and the third is permanent DNA damage. These last two scenarios are often correlated with cancer because radiation can cause DNA damage that can lead to mutations that can lead to cancer formation and then metastasis. Permanent cell death can also be used in radiation treatments for cancer when the affected cells are targeted by more radiation and the DNA damage is so great that the cell is unable to live. So in my research, we are focused on the first scenario, which is full DNA repair. This scenario it occurs when the affected cells have the ability to efficiently and accurately repair the double-strand breaks through DNA repair genes. This is the case with Halobacterium salinarium, which is shown here on the far right. It's the pink organism. It's incredibly resistant to radiation damage with an LD50 dose that is almost 2,000 times that of humans. So studying the genes and mechanisms that are involved with radiation repair allows us to better understand the mechanisms behind how halo is so resistant to radiation damage, and we can apply that to many other organisms. So in my lab, we're looking at trying to identify these genes so that we can knock them out or in and determine where the radiation resistance comes from and how we can apply that to organisms like humans or other microbes. Thank you.
Thank you. All right. Again, the poll will come up for our guests, and the judges have their judging forms. And we'll be moving on to our next participant. Our next participant is an undergraduate in the mechanical engineering department, Sarah Langtob, is that correct?
Langtob.
Langtob, okay. And the presentation is, these boots are made for walking, astronaut boots that improve moonwalks.
Can you guys hear me okay?
Yes.
Okay. All right, I think I'm ready. All right, my name is Sarah Langtob, and I am presenting today, these boots are made for walking, astronaut boots that improve moonwalks. My team and I, we have been working on this project since last semester. We are definitely trying to improve the way astronauts walk in space, especially the moon. We, one of the things that astronauts had a lot of challenges during the Apollo missions, as you can see it on the suits, is how much dust it collected on them. For this reason, we want to assist the new Artemis missions to improve the dust collection on the suits by improving the boots. One of the problems that astronauts had when being on the moon was lack of traction on their boots, as well as the lack of field of vision through their helmets. By improving the boots, we will be improving the way they walk by giving them a sensor system to the boots, and also by reducing the surface area where they are walking on. As you can see from the picture on the screen, the boots are going to be very cleat-like looking. That's the part that where we're reducing the surface area. We're integrating these studs into the boots, where we are reducing not only the surface area, but also adding a rubber, silicone rubber to the tips that assist on the grounding for the suits, meaning that the lunar regolith is electrostatic, and it can produce discharges of electricity on the suits that could fry part of the electronics that they have on their suits, as well as anything that they could touch in the cabin. For that reason, we are also including a shock absorber, kind of like, think of it kind of like a car. With that shock absorber, we are allowing the boots to morph themselves and be able to see if you walk over a rock, they are able to morph and you are not tripping on them. With the sensory system, which is the third one, we're integrating socks to it that have sensors in them that send a signal to the feet of the astronauts. That way they are able to feel what they are stepping on. So we're connecting all these 3 layers into one boot that will help the astronauts to have the sensors to feel what they are stepping on, and with that they can walk better on the moon, have better traction, and they will be able to perform better duties while they are out there. Thank you.
Thank you, Sarah. And again, a poll will appear for our visitors. If you can give Sarah some feedback, and the judges, you can use your judging form. And we have our next presenter, a graduate student from the chemistry department, Wong, and her presentation is entitled, "How Lipid Changes in Breast Tumor Cell Membranes May Influence Radiation Therapy Outcomes." All right, are you ready?
Yes, can everybody hear me? Okay.
Yes, yes.
All right, I'm ready. Cancerous tissue often experience low oxygen conditions, namely hypoxia. Going into details, oxygen enters cells by diffusion across the phospholipid bilayer membrane. So as the left image showed, when the tumor cells grow too fast, the regions which are far away from the blood vessels experience limited oxygen supply, forming the regions of hypoxia. In turn, the proliferation of tumor can be promoted by hypoxia. Hypoxic tumor cells are resistant to radiation and chemotherapy because they need to transfer intracellular oxygen to reactive oxygen species, which could cause DNA damage, even cell death. It is proved that in the presence of oxygen, the effectiveness of radiotherapy can be enhanced 3 times. In one word, oxygen transient through the membrane is significant for cancer research, since it can change the hypoxia condition and then increase the radiotherapy effectiveness. Our group is interested in understanding how the membrane composition affects the oxygen access. In particular, we have calculated oxygen permeability, which is the ability to let oxygen go through the lipid bilayer. The image on the right is one of our systems, which is generated by a physics-based modeling technique, namely molecular dynamic simulations. Lipids are like tadpoles, but with 2 tails. To form the membrane, these tadpoles would arrange parallelly head to head, tail to tail. To form the membrane, in principle, we obtain most of our membrane lipids from food instead of synthesizing them. But researchers have found that that the contents of some newly synthesized lipids are abnormally high in breast cancer cell membranes compared with the normal ones. Specifically, more of the ones and aggressive tumor cells have higher level of long-chain saturated phospholipid tails. Based on the data, newly synthesized lipids which have diverse chain lengths do affect the oxygen permeability. Therefore, these newly synthesized lipids might contribute to the tumor cell hypoxia if their effects on oxygen permeability be preserved in real biological membranes. The insights from this work may lead to new strategies for personalized radiation therapy treatment. And thank you all for listening.
All right, thank you. And a poll again will appear for our guests to give some feedback, and our judges can use their scoring forms. And we move on to our next contestant. Coming to us also from the Mechanical Engineering Department, a graduate student, Christian Peterson. His presentation is entitled Evolution of an Explosively Driven Product Gas Cloud Interface.
Hello. Can everybody see and hear me?
Yes, absolutely.
Excellent. So, understanding explosive events such as is an important component of designing weapons for our national defense. The pinnacle of explosive power can be found in nuclear weapons. The study of nuclear weapons, however, is based on data that is collected from historical tests that cannot be repeated. It is important that we're able to make the most of these tests by applying advanced techniques to extract further information from historical data. Specifically, I am interested in applying image processing to study the mixing behavior between explosive product gases and the air. In explosives, a gas cloud is typically represented by the fireball. Improving imaging processing techniques allow the detection and tracking of fireballs from high-speed video in methods that are both reliable and fast. Part of imaging fireballs is use of refractive imaging techniques such as Schlieren. Schlieren imaging allows the visualization of the first derivative of refractive index, which is directly related to both density and gas species. Schlieren can be a very sensitive and powerful tool for identifying disturbances in atmosphere, such as the picture on the bottom left, which shows the sound wave produced by a hand clapping. I can apply Schlieren imaging to look more deeply at explosive events, like the shotgun primers being imaged in the upper right corner. These images allow us to identify the product gases produced by an explosion and to identify important features, such as shock waves, turbulent flow features, and the beginning and end of a mixing interface. By using shotgun primers, I can generate the necessary complicated flow features in a safe and controlled manner that allows for large sample sizes while still enabling scaling to larger explosive charges. The evolution of the gas cloud interface can be tracked as it evolves through different geometries, which allows me to study the way in which the complexity of a mixing interface changes with time. The bottom right corner shows an example of an extracted product gas interface and the mixing region thickness. The peaks and valleys in the mixing interface are readily identified from the images, which gives us a time history of both the radius of the gas cloud and its mixing region, which allows for deeper analysis. So why do we study the gas cloud? The data collected and models developed over the course of this research will help validate and inform numerical models of how an explosive product gas cloud evolves with time. The evolution of the fireball, and therefore the product gas cloud, is an area where conventional explosives have the potential to differ significantly from nuclear weapons, and understanding the difference will help us inform not just applications, but also our understanding of the underlying physics. Well, looks like I talked fast, so I'd like to acknowledge that my work is sponsored by the Defense Threat Reduction Agency under a DTRA grant. Thank you very much.
Thank you. All right, a poll will appear for the guests. Judges can do their thing. And our next presenter, a graduate student from the chemistry department. This is Hansen Dube, and his presentation is entitled Using Molecular Simulations to Interpret Electron Paramagnetic Resonance Oximetry Measurements in Cells. Hansen?
Hello, can everyone hear and see me okay?
Yes.
Excellent, I think I'm ready. So my name is Hansen Dube. I'm a graduate student in chemistry, and my research concerns electron paramagnetic resonance oximetry, which is a spectroscopic technique used to measure small molecules with an unpaired electron. So on the left, you can see 15N PDT, which is called that's a type of molecule called an EPR spin probe. And you can see we have an oxygen with a free electron. And we can use EPR spectroscopy to image or essentially take a EPR spectrum of that oxygen. And we can see that spectrum on the right. And when we put this molecule in different environments, so the red line is a nitrogen purged atmosphere, that's in the absence of oxygen. And we can see that there's a very small line width and a very sharp peak. On the other end, we have the green line, which is an oxygen saturated atmosphere. We can see that the line width is very wide and we have very hard to detect peaks, very small peaks. The intermediate condition is the air saturated black line, where we have a line width in between that of the nitrogen purged and the oxygen purged systems. So what we can see here is we have a peak sharpness that is proportional to oxygen concentration. So when we have a very sharp peak, we have no oxygen in the system, and a very dull peak indicates that there is a high oxygen concentration. So what we can do is we can take a cellular membrane, such as the one displayed in the center here, and we can insert into it a EPR spin probe, such as 15N PDT here. And we can take an EPR spectrum of our probe and determine the oxygen concentration at an exact point in the biological membrane. However, the location at which 15N PDT exists in the membrane is not known at this time. So we propose an in silico molecular simulation, which is essentially modeling the forces that all of these molecules would experience. We propose modeling our spin probe in the context of a biological membrane to determine both the location of the spin probe, and then we can use that to determine the concentration of oxygen at the point in the membrane. And the reason that's important is we see a correlation between high oxygen concentration in, say, cancer tumors and a increased patient survival rate and increased tumor death rate. So in short, if we're able to measure where in the membrane our spin probe is, we're able to accurately take an oxygen concentration at that point in the membrane, and that can inform chemotherapy and radiotherapy for difficult to treat cancers. I believe that concludes my presentation, so thank you.
Thank you. All right. A poll will appear for our guests, and you can give Hansen some feedback. And judges, you can do your thing. All right, so our last presenter is Anthony Morgan. He's a graduate student in the Petroleum Engineering Department, and his presentation is entitled A Gate-to-Gate Life Cycle Assessment for the CO2 EOR operations at Farnsworth Unit, FWU. Anthony, are you ready to go?
Yes, I'm ready.
Okay, let's start the timer.
Hello, everyone. I'm Anthony Morgan from the Department of Petroleum and PWRC. My work is on a gate-to-gate life cycle assessment of the CO2 enhanced oil recovery operations of the Farnsworth unit in Texas. And as you can see from the schematic diagram there, the gas is produced and captured and is transported to the oil field, where it is injected into the formation, and then as the gas CO2 is injected into the formation, it mixes with the crude oil, and viscosity of the crude oil reduces. And as viscosity of the crude oil reduces, it increases the mobility of the crude oil, and this crude oil can move to production wells, enhancing production of this crude oil. So in partly, a part of this CO2 also remains in the formation and it is stored without it being emitted into the atmosphere. So the essence of carbon sequestration is to reduce global warming. And though the CO2 from these anthropogenic sources are captured and injected, the operations involved in this activity also contribute to emissions, which in most instances are not accounted for. So this study focuses on evaluating the greenhouse gas emissions of the Farnsworth unit, carbon dioxide enhanced oil recovery operations. Hence, the life cycle assessment framework by International Standard Organization and plain CO2 reduction model were employed in this study. So I looked at two scenarios. One is based on the current Farnsworth unit operations conditions till date, and secondly, a forecasted carbon dioxide enhanced oil recovery operations for 18 years, which includes an optimization of current operational units to ensure a net zero carbon emissions and a higher CO2 storage volumes as compared to current operational conditions of the Farnsworth unit. There's possible units to be recommended to improve can also be identified at the end of the analysis. So from the first scenario, analysis yielded 79% of the purchased CO2 or purchased anthropogenic gas, as against 2% of the CO2 purchased or without life cycle assessment, and improving conditions with reduced emissions. 86% was estimated for the optimized model. So venting and flaring, as well as energy usage from the analysis, were noted to be the highest contributors to emissions. Thank you very much.
Thank you. All right. Another poll will be coming up, and judges, you can do your thing. And I believe that's all of our presenters for today. Sarah, did I miss anyone?
Nope, everybody had a chance to present.
All right. Well, we'd like to first of all give a round of applause for our presenter today. Thanks all of you for participating in the 3-minute speech competition. And we have show of hands popping up icons. Just to let you know, the judges and I are going to be separating out into a different Zoom room where we will deliberate and come up with the winner. And the winners, the top 3 will be announced later today. Of course, we're also available to make sure that if you have any questions, we can let you know a little bit about some of the things that the judges commented on, also in addition to the feedback that you'll be getting from the general polls that were taken during your presentations. Thanks everyone for coming to watch us, and thanks for to all of the SRS organizers for helping us get this together. We should give also a special round of applause to Sarah Obendorf. Could you come out and show yourself? Obenoff, excuse me. She was the master behind all the technology that kept all of the wheels rolling. And also Sophie, you want to show yourself?
Hi.
Sophie helped as well. So these are some of our SRS workers who helped make this possible.
Thank you, Steve.
All right. Have a good day.
Thank you all.